In this section, we are going to discuss about multiplication of two complex numbers. So let us begin by considering complex number z1 equals to a1 plus I times b1, and another complex number z2 is equals to a2 plus I times b2. We're going to multiply them. So z1 multiplied to z2 is simply equals to a1 plus I times b1 times a2 plus I times b2. That will be equals to a1 multiplied to a2 plus I times b2 plus I times b1 multiplied to a2 plus I times b2, which is finally equals to a1 times a2 plus I times a1 times b2 plus I b1 times a2 plus I squared b1 times b2, which is equals to a1 times a2 minus b1 times b2. Now minus b1 times b2 came from the fact that I squared is equals to -1. So that means I squared b1 times b2 becomes a real number because I squared is -1. So we're combining with the real part a1 times a2. Then we have the imaginary part, which will be a1 times b2 plus b1 times a2. So this is how we multiply two complex numbers. Let us take a simple example. So let's say we have z1 is equals to 2 plus 3i and z2 is equal to 1 plus I. So we're going to multiply z1 and z2. That gives us 2 plus 3i multiplied to 1 plus I, which is 2 times 1 plus I plus 3i times 1 plus I equals to 2 plus 2i plus 3i plus 3i squared. So that is equals to 2 plus 5i, 2i plus 3i gives us 5i plus 3 times -1. Since I squared is -1, then we combine 2 to -3, which will be the addition of the real parts, and the final answer will be 2 minus 3, which is -1 plus 5 of I. Now we discuss about the different properties involved in the algebra of metric complex multiplication. So properties of complex number multiplication. We talk about the first property. So first property is that multiplication is commutative. Meaning, if we have two complex numbers z1 and z2, then z1 multiplied to z2 is equivalent to z2 multiplied by z1. So I'm leaving the proof as an exercise where you can check by assuming that z1 is equals to a1 plus I times b1, then z2 is equals to a2 plus I times b2. So we can multiply z1 and z2 times a2 plus I times b2, and that will give you the required result. The next property is that multiplication of two complex number is associative in nature. So that means if we have three complex numbers z1, z2 and z3, then associative means that we take z1 and multiply to z2, and then we multiply the result to z3, and this is same as saying we take z1 and multiply it to the product of z2 and z3. You can also check the proof. I'll leave it as an exercise for you. Then we move on and go to the third property, which is the existence of an identity element for multiplication. So in order to understand the existence of identity element for multiplication, we consider a complex number z1 equals to 1 plus I times 0. This is a purely real number. Now what it means that if we have a general complex number z given by a plus I times b, then we take the product of z with z1. So let's do the multiplication. We have a plus ib multiplied to 1 plus I times 0, and that should give us a plus I times 0 plus ib times ib multiplied to 0, which finally gives us a plus 0 plus I times 0 plus b, which is equals to a plus I times b, that's equals to z. So that means multiplying a complex number z by its identity element z1, which is 1 plus I times 0, gives us the original complex number. So 1 is an identity element. So the next property we are going to talk about, the multiplicative inverse. Multiplicative inverse. So that means given complex number z, there exists another complex number which when multiplied to a complex number z gives us 1. So that means we are dividing both sides by z, which gives us 1 over z. So this is the multiplicative inverse. So we replace it. That means if we have z and we multiply it to its multiplicative inverse, which is 1 over z, then that gives us the identity 1, or simply 1. So this is known as the multiplicative inverse of a given complex number. For example, let us consider z is equals to 2 plus 3i. Then the multiplicative inverse will be 1 over z, which is equals to 1 over 2 plus 3i. However, we know that 1 over 2 plus 3i is not in the standard form, so we have to convert it into a standard form, but for that we need the concept of conjugate of a complex number, which we're going to cover in the next lecture. So for the time being, we just stick with this, that 1 over z will be the multiplicative inverse of a given complex number z. Now let us talk about division. We have division. The concept of division means given two complex numbers z1 and z2, then we can divide a complex number z1 by z2. So assuming that z1 has the value a1 plus I times b1 divided by z2, which has the value, let's say, a2 plus I times b2, then this is how we can divide any complex number z1 by z2. Then using the concept of conjugate of a complex number, we can convert this into our standard a plus ib format. So this is how we divide two complex numbers. Let's say our complex number z1 is equals to 2 plus 3i and z2 is equals to 3 plus 2i. Then z1 over z2 is equals to 2 plus 3i divided by 3 plus 2i, and we'll have to do some more calculation here, and that will give us some standard complex number, which will be a plus ib. So we'll be doing some more numericals. Before that, we have to cover one topic known as the conjugate of a complex number that we'll cover in the next lecture.